and welcome back to our course in trigonometry. In this video we are going to discuss the right triangle definition of the 6 trigonometric functions. So let's go over that little labeling convention that we had for our triangles. So remember, we will denote angles with capital letters. So capital A denotes angle A right here, capital B is angle B, capital C is angle C. Now the convention is that angle A opens up onto side A. So notice the angle gets the capital letter, the side length gets the lowercase letter. So this would be side B and this would be side C, and in this right triangle. So, cosine of angle A, sine of angle A, and tangent of angle A. Now, if you have seen trigonometry before, perhaps in a high school course, or maybe a pre-calculus course or whatever, you might remember that cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse, and tangent is opposite over adjacent. Now those are relative terms. It depends on what angle you're talking about. Okay, so this is the opposite side if we're talking about angle A. So if we're talking about angle A, that's the opposite side. This is adjacent to angle A. And of course that's the hypotenuse. So if I'm talking about cosine of angle A, I want the side that is adjacent to angle A over the hypotenuse. The adjacent side over the hypotenuse. If I want the sine of angle A, I want the opposite side over the hypotenuse. If I want the tangent of angle A, I want the side that is opposite angle A over the side that is adjacent to angle A. Okay, if we use the letters here, this would be B over C, this would be A over C, and this would be A over B. All right? So cosine, adjacent over hypotenuse, sine, opposite over hypotenuse, tangent, opposite over adjacent. Now we can get the other 3 trig functions using our identities that we talked about earlier in this course. To get the secant, you take this and flip it, hypotenuse over adjacent. To get the cosecant, you take the reciprocal of the sine function, hypotenuse over opposite. To get cotangent, it's adjacent over opposite. Let's look at a quick example. In triangle ABC, with C equals 90 degrees, let's take side A to be 12 and side C to be 15. Find all 6 trig functions of angle A. Find all 6 trig functions of angle A. So let me draw myself a picture here. Okay, wait. I'll be happier if I do it like this, but so that's A, that's B, that's C. C is the 90-degree angle. They told me C was 15, and they told me A is 12. Now remember, angle A opens up onto side A. That 12 has to go here. We got to get these triangles right because we're using this stuff to get the value of our trig functions. If I don't put the 12 in the right spot, all my trig functions are going to be scrambled. Okay, now, they didn't tell me this side. However, we know the Pythagorean theorem, so we can find the length of that side. This is b. Okay, what's b? Well, I don't know yet, but I do know that 12 squared plus b squared equals 15 squared. 12 squared, 144. 15 squared, 225. 225 minus 144. Okay, so 225 minus 100 would be 125 minus 40. I'm at 85. Yeah. I think so. So 225 minus 144 would be 81. Hold on, I'm going to go check that with my calculator. 225 minus 144. Yay, I got it right. 81. Okay. So B equals 9. Oh, okay. It's a 3, 4, 5, right? It's a multiple of. No, it's not. Yeah, it is. 3 times 3, 3 times 4, 3 times 5. Okay, great. So B is 9. Okay, now that we've done that, we can get our trig functions. Okay, so we're talking about angle A here. Cosine A, opposite over hypotenuse, 12 over 15. We can reduce this fraction, 4 over 5. Nope. Cosine is adjacent over hypotenuse. 9 over 15. 3 over 5. Okay, I've got it written right here, right? I should have seen that. Cosine is adjacent over hypotenuse. If we're talking about angle A, there's the adjacent side, there's the hypotenuse. 9 over 15, 3 over 5. Sine of angle A, opposite over hypotenuse. 12 over 15, or if we reduce, 4 over 5. Tangent of angle A, opposite over adjacent, 12 over 9, we can reduce, 4 over 3. Now that we've got these three, we can use the reciprocal identities to get the other three for free. Secant of A, 5 over 3. Cosecant of A, 5 over 4. Cotangent of A, 3 over 4. Now, one thing I want to emphasize about the importance of understanding what angle you're dealing with. If I were to talk about angle B, if I'm talking about cosine B, well, I'm still going to do adjacent over hypotenuse. But if I'm focused here on angle B, the adjacent side's right there. If I'm at angle B, there's my adjacent side. The hypotenuse is, of course, still 15. So cosine B would be 12 over 15, or 4 over 5. If I take the sine of angle B, well, once again, my focus is here. The side opposite B is this one, the side with length 9. 9 over 15 is the sine of angle B. So notice these things are swapped. Incidentally, that's why the function is called cosine. Okay, this is a right triangle. So the angle sum has to be 180, right? This is a 90-degree angle. So these two angles have to add up to be 90 degrees, because that's the amount of angle measure that we have left. So these two angles are complementary. So sine A, cosine B, they're the same. Cosine is complementary angles sine. That's why it's called cosine. Okay. So another thing I just want to emphasize, that make sure you understand what angle you're dealing with, because that determines what the opposite side is and what the adjacent side is. Okay, the opposite side is the one that's completely across from your angle. Your angle opens up onto the opposite side. The adjacent side is the one right next to it. Okay, so, and might as well just finish it off. If we're talking about angle B and we take the tangent, well, the scheme that we had at the beginning of this video still applies. Tangent is opposite over adjacent. If we're talking about angle B, the opposite side is the one with length 9 over 12. Okay, so we have now two ways of thinking about the trig functions. We have the procedure that we used at the beginning of the course, angles in standard position. That's very useful for extending the definition of the trig functions beyond acute angles. And we have this right triangle definition. As we'll see later in the course, just a few videos down the road, this is very useful for those indirect measurement applications that I talked about at the beginning of the course. So, right triangle definition, very good for indirect measurement. The angle in standard position definition, very useful for extending the trig functions beyond the domain of acute angles. For example, if I wanted to talk about the cosine of 135 degrees, it doesn't make sense in the right triangle definition world. It does make sense in the angles in standard position world. Okay, so you're talking about cosine, adjacent over hypotenuse, sine, opposite over hypotenuse, tangent, opposite over adjacent. Okay, make sure you commit that idea to memory. We're going to be using it a lot in the course. Okay.